Hey guys, welcome back to the shop. So we have a repair job to do here. This is a bandsaw wheel out of, I believe it was a Delta bandsaw. Belongs to a local factory here. But there's a company in town that sells woodworking machinery and equipment, and they're the ones that brought this to me. So apparently the problem with this particular wheel, and they've actually had this problem already a couple times, is the bearing fit on one side of these wheels here gets wallered out. You can see the bearing just drops in there, and it's got a little bit of wiggle room. There's a bearing on this side there as well. That one's still pressed in there nice. The factory does machine snap ring grooves inside there, and they just put snap rings to create a shoulder for the bearing to press up against. So anyway, they brought this to me asking could we go ahead and fix the bore so that they would have a good part to keep on the shelf as a spare. They've already replaced this for their customer. They ordered a new wheel, got it in, and got it replaced. But there's nothing wrong with this other than that one side, that bearing fit. All of this looks pretty good. So they just want to have a good spare part so that in the event that one of these wheels wears out again, and it probably will, they'll have one already there that they can put onto the machine while they get another part, ordered to probably keep on the shelf. So that's what we're going to do. We're going to go ahead, and I think the approach we're going to do is we'll pull that snap ring out of there, and I've got a piece of steel tubing right here that we can use to machine a sleeve. So we'll set this up in the lathe, bore this out, I don't know, maybe about halfway down in there. Bore this out. I'm not sure what size, but probably kind of split this, take no more than half of this wall thickness there. And then we'll set this up and machine a sleeve and get it probably shrunk in there. And then finish the bore size to the proper fit for the, I believe this was a 6203 bearing. Yeah, 6203 to give it the proper press fit down inside there. So some good manual machine work right here. We'll probably go to our American pacemaker to hold the wheel itself, do the boring, and then we can go to the smaller lathe, the Precision Matthews, to machine our sleeve. All right, so we'll get started on it. I'd like to go ahead and give this guy a wash and get some of this powder off of there. I know it's a product that they use to make ceiling tiles. I'm not sure exactly what it is, but it is a white powdery substance, kind of like drywall. Just use the smart washer and wash this guy off. All right, we got to get this snap ring out of there. There we go. There's our snap ring. I doubt that we're going to fuss with a snap ring and a snap ring groove on our repair, since all it is just to hold the bearing in place. Whenever we go to bore this out, we'll bore it past the snap ring groove a little ways just to kind of clean that up. And then whenever we machine our piece of tubing, this guy right here, we'll have a shoulder down inside there for the bearing to press against. We'll just measure what like the inside diameter of this outer race is, and just have a step in the tubing so that when it's pressed in there, it'll just come up to a shoulder and stop. I think that's how we'll take care of that. All right, so now we can go over to the lathe and start getting this guy trued up. Okay, we've got the 4-jaw preset to our diameter, which is about 16.5. There's a couple ways that you could chuck this and hold it. One, on the outside of the wheel like we're going to do here, but you could also technically chuck it right here on this hub and indicate it just the same. But I already had 2 of the jaws flipped out, turned around on this chuck, so I just went ahead and decided let's just chuck the outside right here. And since they've got an area machined on this hub, we can use that to indicate on. All right, so we've already got these set about where they need to be. So we're just going to set it on there. And this rubber band on here actually is providing a pretty even stop for the jaws to kind of push up against. We'll still have to indicate this and make sure it's straight. I also want to line up on the inside of the casting here, give it just a little bit of added rigidity as we clamp on it, so it looks like it's lined up with the 4 jaws. Doesn't take a lot of pressure here either. Got to be kind of delicate with these kind of castings that you don't over squeeze it. It ain't going to take a lot of pressure. All right, so we've got the 4 jaws. Let's see how far out we are. I don't know, maybe 50, 60 thousandths. So our face here is machined, so we can reference this face here as well to get it trued up. We got this face is machined, so we can use that. So these should be in line. Then we have this area that's turned on the outside, and we'll use that to indicate the concentricity of it and get it indicated. We might even flap the inside of that with some sandpaper and then check the ID to see if it matches with this turned OD. But technically the factory should machine all this at one time, so you have reference surfaces to indicate on when you're lining this stuff up. So first thing I want to do is go ahead and get the face of it bumped around. I think we'll just go ahead and start on this outside flange here. Make sure it don't run off the part there. So it's going to be warped a little bit, just the nature of a casting like that. So we'll use this and get it kind of close, and then I'll check it there on that inside hub. So that's high, that's a little high, that's a low, that's a high. So let's go ahead and tap that one a little bit. In this case, we want to try to get them about as even as we can. I'm going to go ahead and raise this up. That way it's kind of in the middle of the jaw as we bring the jaw directly in front of me. This one needs to go in just a bit. I'm worried that might be running off, so it's good there, about 2 under, and it might be hitting this chamfer. I think that's why it's dropping out right there. All right, so let's go ahead and move this indicator to this hub and go ahead and get it kind of trued up that way. So just stick an indicator right there. It should clear the spokes. Oh yeah, I was out quite a bit, way more than I thought I was. Go ahead and start with the highs and just make sure that the jaws are tight, since we don't have a lot of pressure on this thing. This is where you're going to loosen your low, tighten your high, but you kind of do it equally. So we're just kind of moving it, we're pushing it one way, little at the time, making sure you don't loosen it up to where it's going to fall out of there. Now we're about 100 thou. Just keep loosening the low, tightening the high. It's sort of in the middle now, but we'll go back to this one. Loosen, tighten. Now we'll have to go to this one as your low. That's your high. That one's pretty well loose already, so we're going to snug this one up. Let's tighten the high since we're less than 10 thou. Low, high, low, high. So now we're close enough here. We're within 2. We need to go back to the face. Another high. It's really easy to get the OD dialed right in, less than 1 thou. But we got to make sure that the face is true as well. So that's under 1/1000ths run out on that hub there. So let's go ahead and we'll just indicate this face. This out here is going to be a little more wavy, just the nature of a cast piece like that. Now that we're in the center, we shouldn't have to worry about it running off of that face. Look how close that is. I mean, that's less than 1/1000th. I don't even know if it's worth touching, but you know me. Let's see. So with a 1/1000th resolution indicator, we're a 0.5 off on that face right there. So that should be good. We shouldn't have to worry about, we're not going to worry about where this flange is at. It's going to run the same place that this is here. But we want to make sure that you're indicated where the bearing goes. That worked out pretty good. I'm going to go ahead and check this OD again now that we're basically there, and we can go ahead and try to get that last 1/1000th of an inch out of this if it's still in there. And usually whenever you bump the outside, that moves anyway. So where are we at? Not quite 1/1000th. This is going to be your high. So we're going to take this and just barely move it. Nothing wrong with that at all. Now, I'm going to call that good, but what I want to do is make sure that all 4 of our jaws are snug, that you don't have one of them loose. That one felt a little bit loose. That one felt a little bit loose. That one's tight, and then this one's tight. So that probably moved it just a touch, maybe a 1/2 thou, but I think we're good right there where we're at. All right, let's fire up the lathe and see what it looks like running. It's looking good. You can see that little bit of waviness on this outside flange right there, which is going to be normal, but we know that our hub is trued up nice with that machine face right there. I'm looking back here on the back side. I can see the other bearing, and it looks like it's running nice and straight. So I went ahead and took this little flap disc here and cleaned out that inner bore, because that should all be machine true. And I want to go ahead and check this and see if this is running true with this outside of that hub there. So let's give that a go. What I'm going to do, we've got our dial indicator, and I'm going to use my number 670B ID attachment. This is made by Starrett. This is my favorite attachment for getting on the inside. Just makes it super convenient. Just put it right there on top of the indicator like that. And then you have this arm that's going to transfer the movement. So get this in here. Just kind of get it lined up about in the middle. Put a little preload on it. All right, let's see. Oh yeah, that is not running true with the OD of that hub there. So it looks like we've got, that's 4 and 4. So that's 0.8 difference from the ID to the OD. Now keep in mind, I'm not measuring where the bearing journal is, where the wear is. We're in between the 2 bearings. So nothing should ever have rubbed that. So that means that I don't have it true with that other bearing in there. So let's go ahead and adjust this. Our face should be good. That's going to be our high. So we're going to do it opposite this time since we're on the ID. I want to loosen the high and tighten the low. In this case, we're going to go ahead and adjust the low. Just want to make sure it's snug. And let me make sure you guys can see this okay. Maybe you can see that just a little bit better. Okay. Loosen the low. I'm sorry, loosen the high, and we're going to tighten the low. Just a little bit, a little bump of the screw. Half a thou. So let's go to our low right there. Let's see if I can move it a little bit. Pretty darn good right there. It's still just barely moving. So that's less than a thousandth run out right there. I think that's going to be good. So while we're there, we can go ahead and let's compare it to our bearing ID. So we're looking at about a thousandths difference. I think that's going to be good to go. Let's go ahead and fire it up. See how it's going to run. It's 330 RPM. I'm looking at that back bearing. It looks good. Should be good to go right there. You're gonna see what looks like run out here because that bearing journal has that wear in it. Looks pretty good. I think we're gonna roll with it just like it is. Our face looks nice and true. Okay, we've got our bar set up. Decided that we're gonna go 0.687 deep. That'll clean up the snap ring groove and give it I don't know, about another 1/16 or so. And as far as the bore diameter we're gonna go to, I kind of split this in half. So we have a 1-inch 575 bore, 2-inch 150 on the OD. I just kind of took about half that. That puts us at 1.825. So that's the diameter that we'll probably shoot for, or even 1.8. The diameter that we'll go back there and clean that up. And then once we have this bored, then we'll go take our piece of steel tubing and machine the sleeve that's going to go in here. So we'll get our tool established on our Z-depth. What I'm going to do is just touch that face. All right, there we go. We're just touching the face. Go ahead and stop this spindle. And then we're going to use this indicator down here. This is our carriage indicator, mag back carriage indicator. And I'm going to use this like our DRO. So we'll set a 0. We got a 0 set, so I'm going to go ahead and establish our depth. So we're going to go 687, which is 11/16. So 1, 2, 3, 4, 5, 6, and we'll go to about 82. That'll give me about 5 thousandths to clean up that back face there. Go ahead and just reset this to a 0. That'll be our stop. There's another one of our carriage indicators right there. And whenever I'm doing the boring operations, it's very convenient for me to use one right here as well. It's got the fence so you can push it and it's nice and in line. And that gives me a nice indicator reading there for our movements versus this big dial right here. This just makes it a little bit more convenient to dial in those few thousandths that you want on the cross slide here. I think we're ready to start boring on this thing. We've already got our cut established. We'll be just taking like 50 thousandths a pass here. There's a snap ring groove. And there's our stop. Got to be careful not to let it rub there because don't have a lot of rigidity in that center. Take another 50. Sounds like it just cleaned up that snap ring groove. Just giving it a double check with the calipers. We're good. Got a little over 100 thousandths to come out. Probably just make a couple more cuts here. All right, now we'll go ahead and use our telescope gauge and mic and see what diameter we're on. Let's use one of our Starrett telescope gauges. And our 1 to 2 micrometer. Should be close to 1.8, just under that, I believe. Yep. 1.798 is where we're at. So what we'll do is, I'd like to clean that up. So you need to split your finish cuts. So we'll take a 10 thousandths cut here and then measure it again and take our final. So we'll go 5 thou on the dial indicator right here. That's going to be 10 thousandths total. Just getting the chips out of the way so you don't mic them, don't measure them. Make sure there's no fuzz sitting in there that you're measuring. Let's see. Yeah, we ended up taking 11 thousandths right there total. So we're going to want 10. 16 thousandths is what we want if we want to make it 825. That's 10, 15, 16, yep. So I'm going to take 8 thousandths on our dial indicator over here on the cross slide. 8 thousandths. All right, we're lined up on the 5 mark, so there's 5, 6, 7. Usually go just a little shy because once you start moving the carriage, it usually adjusts just a little bit. So there it is on the 8 thousandths mark right there. Trying to chatter on that face. I was going to clean up that back face a little. That's okay. Let's see if I hit my target. I'm shooting for 825. It actually went over a thou that time, so I did not hit my target. We're at 826. Nothing wrong with that though. That's not a real critical measurement. 826. So we'll try to make our sleeve maybe about a 0.5 thousandths larger than this diameter here. So the only thing left to do, we need to go ahead and cut a little chamfer on that. I'm gonna have to swap out this tool for another one. So we'll just get this chamfer done and we'll go ahead and start making our sleeve. We made it over to the Precision Matthews manual lathe, so we got our piece of tubing chucked up. Just gonna make our sleeve as needed right here and part it off. And what I'll probably do is once this is parted off and ready to go, we'll stick it in the freezer and freeze it for a while, let it get good and cold, and hopefully that'll be just enough for us to be able to take it out and slip it into that wheel and let it set. And hopefully it'll be done at that point, but we'll see. We're just gonna do our standard work here. We're gonna face it, bore it, turn it. Just looking for about 1 3/8 with the calipers here. 1 inch 3/76. So now what we'll do, so that's going to match this, let's say the inside diameter of the outer race, so that it's got a shoulder to press against. That's the shoulder it'll press against there. So now we just need to counter bore it. What was the width on this? I can't ever remember. 12. Yeah. So 12 millimeter, that's our depth that we'll counter bore this for a proper fit for a 6203 bearing. All right, so I think what we'll do is just come up and without it spinning, we're just going to touch it right there. And I'm going to go Z is a 475, negative 0.475, enter. Let's see if that's right. Yep, we're going into plus. So now we can just bring our Z to 0. And we got approximately 200 to come out of the ID here. Comes up on that 0 really fast. Try to go about 10 or 20 short and creep up on it by hand. All right, now we need to start taking some measurements. So we got about 24, maybe about 24 thousandths to come out of that. Kicked up our RPM. Hopefully that'll help us get a nice, consistent, smooth finish on that bore there. I've been playing it back and forth in my head whether I should go ahead and finish this to size and stick it in there and see if it stays there, or leave this undersize, put it in, and then bore it. The second option is probably the better, but the problem is that you're talking a small diameter there in steel. It's better, you can get a better finish over here with their high speeds versus over on the American Pacemaker with them slower speeds, and I don't want to run the guts out of it either, so I'm not going to be spinning that thing super fast. So I'm thinking about rolling the dice and finishing our sleeve bore and shrinking it in there and seeing if it stays where it needs to be. Even if it's slightly under, we can easily kind of polish that little bit out. So we still got about 10, 11, and 12, so about 12 thousandths to go. So let's sneak up on it. Take a 5/1000 pass here. Probably take 2 more cuts here, maybe just 1 cut. So we've got about 5, 6, got about 6/1000. So I'm going to take a couple of measurements here just to verify that I'm reading it correctly, that I'm getting a good measurement, and then we'll make our final cut. I usually do these about 3 times just to be sure. Okay, let's see if we can make our finished pass here. All right, let me see where I hit it. Got a nice smooth bore to it. I can feel that just with the telescope gauge. All right, I think we landed exactly on 575. Yep, 1.5750 is what we got. So that is 2/10 over. Let me look at my chart here. Minimum 1.5748. And then maximum 1.5754. So I usually try to kind of split the middle of it there on the tolerance. So I think we're good. We're going to put some chamfers on these edges here, and then we'll finish the OD and part it off. I got a threading bar there, kicked around a couple notches on the multi-fix to serve as a chamfer. Go in there and break that other shoulder inside there. All right, on to the OD. I've already remeasured our wheel, wrote down our measurement, so my target is to give it a 0.5 interference. And I'm hoping that we can freeze it and shrink it in there. So we've got 175 thousandths to come off of this OD right here. Just taking light cuts on this. 50 thousandths a pass, don't have much to come off. Take another 50 here, and we'll let it cool down just a bit, and then start our finish cuts on it. All right, let's see where we're at. Should be about 1 inch 850. 856, yep. Starting to get warm. We'll go ahead and take another cut and get it a little bit closer. Take another 20 thou. And then for our final cuts, we'll speed that chuck up and see if we can get a good finish on our last cuts. All right, so we're just gonna let that cool a minute. I could probably turn the coolant on there, but it's not gonna take much. It's not gonna take much to cool that down. Sometimes I just take my air, just so I don't have a mess over here with the coolant to clean up for such a small task. Sometimes I just do that and cool it on down. All right, we're cool to the touch. Let's go ahead and finish this guy. We've got less than 10 thousandths. We're gonna spin this at 1200 RPM, and I'm running a 5 thou feed rate. I'm gonna go ahead and take 5 thousandths. Not very much material to take with those inserts, or that particular insert anyway. So it's gonna string on us like that. But it still does a good job of removing a chip even for that amount of material there. Let's see, this should be our finished cut right here. 5 thousandths. I'm just gonna do this a few times and double check. It's not quite 5. We're looking at probably about 4.5 thousandths. I'm adding up the tenths here. All right, finished cut. Always on the finished pass, it's gonna mess it up. Not a big deal. I just don't want it to rub and then create a burr on there that interferes with the diameter. All right, so see if I hit my target. We hit my target. I was looking for 1.827. I know you can't see it with the GoPro, but we are there. So that's gonna give me about a 1/2 thousandths interference fit inside the bore. So like I said, we'll go ahead and chamfer that. We're gonna part it off and we're gonna freeze it. And hopefully it'll just slip in there at that point. Chamfer tool. And just make sure it doesn't roll an edge over. We're gonna, just like that. We are ready to part this guy off. We got a little brass rod we're gonna use here to catch it. So I'm using a high-speed steel parting blade. I've got that ground with the right-hand lead so that it'll pop the sleeve off and leave the little burr on the material there. So let's go for it. We've already got it offset the proper distance we need. And we're gonna use some of my good old-fashioned dark cutting oil for this. You have a nice grind on there. It's just nice and pleasant without a bunch of extra heat. So before we get all the way through there, what I'm gonna do is just back it straight out. I'm gonna blow a little bit of that oil off so it don't get all over my file. And then take and go ahead and file it like this. I'm going to go ahead and get that little bit of bevel on the back side of the sleeve there established so that it'll go up inside the hole. Trying to eliminate another deburring step is all we're doing. All right, so we'll go back in here. Just doing this by hand too, feeding it in by hand. You can hear it. It's starting to come through the ID. Take it nice and slow and it should just pop off there. Just like that. And you see the burr is left there on the workpiece. You come in there and part that off just like that. There you go. All right, there's our sleeve. Probably go ahead and put it back in the lathe and go ahead and deburr that ID anyway. The OD we got pretty good, but we'll get it cleaned up and then we'll go to the freezer with it. All right, so there's our completed sleeve. Let's see if it stayed on size. 827, it's still there on the OD. All right, so I've already got it clean. I used some degreaser there to get it nice and clean. So what I'm gonna do is I'm gonna put it down in this coffee mug, and we're gonna set that in the freezer. And I'm gonna go ahead and let this rest overnight in the freezer. And then when I get it in the morning, we'll go ahead and pull it out, and hopefully it's gonna slide right up in the bore of that wheel over there. All right, guys, it is the next morning. I'm enjoying my coffee, and I am ready to get this sleeve hopefully successfully shrunk into that wheel right there. So we're gonna get to that here in just a minute. Before we do that, I wanted to correct something that I showed you guys yesterday that I was wrong about. That is the new collet chuck holder that I got from Pee Wee Tools. I've actually got it in the wrong tool holder. I didn't realize that when I installed it. So let me show you what I did and the mistake I made. I want to make sure this is right for you guys that might be interested in this stuff. All right, so this is the new collet chuck holder from Pee Wee Tools I showed you, ER40 collet chuck. And I've got it in my J, the H. D1H 63180. That's the model of this tool holder. So just consider this the H holder. This one's actually designed to go in the J holder. This is the D1J 63180. 63 millimeter bore, and you see how it's designed to work. It's just a split clamp style holder, and this sleeve actually is supposed to go in here. And I was wondering why Peter didn't have like a flat machined on there or ground. It's because this one's actually designed to go in this style holder right there. So I didn't clamp down very hard on this with the set screws, so it should be fine, and we'll just stone those 4 places where the set screws touched it, and we'll make sure that we pull this out and put it in the D1J tool holder. Peter does make this, I know, in the ER32 style, so it'd be the next size down tool holder, and he may have them for some other holders there as well, but I'll have his email in the video description of this video if you guys are interested in anything multi-fix. Parts, holders, complete systems, you can email Peter over at Pee Wee Tools and he can get you fixed up. All right, let's take a look at our sleeve. Should be nice and frozen in there. All right, so I've got it in this mug so that I can carry this out to the machine with less chance of it warming up between here and there. So I'm gonna stick that back in there and let it just stay in its cold state while I get the camera set up, and we'll go ahead and get this guy hopefully slipped in there. All right, here we go. It is not wanting to go. Yep. That's what I was afraid of right there. It is not wanting to go. I've already got my hands on it. It's warming up. It is not going to fit in there now. Dang it, dang it, dang it. I think I'm going to give this another shot with our cold sleeve method there. I went ahead and measured this, and I remeasured the sleeve, and I've got a 1/2 thousandths difference. The sleeve is technically measuring with it cold a 1/2 thou under this bore right there, so it should go in there. It's 1/2 thousandths is really hard to get lined up and get into a hole straight, so I'm either going to really screw up right here or we're going to have some success, and I hope it's successful. So I'm going to try to get it at least started right there. I've got a little soft blow, and I've got this piece of steel here that we should be able to, I'm hoping, bump it lightly. You don't want to be too hard on this because you can break that. And hopefully I can get it tapped straight and just get it right on up in there very quickly. And if it gets stuck, then I'll just wait. I'll stop, we'll pull it out, we'll go to the press. That way you can put it on the hub and then finish pressing it down in there. So I'll go ahead and get the sleeve. We'll give this another try. I've been letting it get cold again. All right, here we go again. All right, I think we got it there. I got it bumped in flush, so it should be good to go. That one had me a little worried. It didn't go as elegantly as I was hoping that it was going to be, especially on video in front of everybody there. But another thing that you can do, you know, is warm these hubs and get them to expand a little bit. I don't have any kind of torch set up here at the new shop, so that's why I didn't put any kind of heat on that. Even a little propane bottle probably would help a little bit. But that was just a very close fit with a 0.5 thousandths difference. And then as soon as you start touching it with your fingers, it starts warming it back up again instantly. But I think we did good right there. We should be good to go. I'm gonna let this normalize for just a few minutes, and I'm gonna go ahead and remeasure that, make sure that we still got a good bearing fit there. Okay, here is the collet chuck mounted in the proper D1J tool holder. And I've got a carbide bar mounted in there. This is one of my Micro 100 half-inch shank carbide bars. So I am gonna use this. I've done some indicating. We're running nice and true on our sleeve, and we are about 6/10 under what I really want to be there for the bore size for this bearing to fit right. So I'm gonna attempt to try to clean that up, just very, very minor, clean it up just enough with our carbide bar here to bring that to the minimum size that I'm trying to get it at. Oh, that's looking good right there. That's looking 1.5750. 5750. Let me do that again. 5750. That made me a little nervous, but we got it. I was able to just clean that little bit of undersize out of that thing. The shoulder doesn't look as good because I came back there to touch to get our 0 point for our Z movement, and it tried to chatter a little bit on that back face, but we're just gonna have to leave that alone. It's just not rigid enough out here, floating in the middle like that. But I feel good now that we've got that bearing on size. Should be the proper fit to easily push that bearing in there. All right, guys, our bandsaw wheel should be good to go here. I remeasured the bore 2 more times, and I'm still getting 1.5750, which should be a good fit for that bearing going in there. So we're done. We're just gonna go ahead and get it out of the lathe here, and this will be finished up. There it is. Once I pulled that wheel out of the lathe and I got a really good look at that inside face with that chatter in it, it just really bugging me, and I couldn't leave well enough alone. So we chucked it back up on that inside hub there, nice and rigid now. I trued it all up, and I went in there with our boring bar and I just took 5 thousandths out of that inside face just to clean the chatter up. I've checked it with our depth mic there, and we're about 7 thousandths deeper total on as far as the thickness of the bearing, 12 millimeter. So it should be any problem there. They'll press the bearing in, it'll go to that face right there, and probably just have a little bit of clearance on the back. But anyway, that looks better. That's more presentable. I don't like leaving parts with chatter in them. So that's gonna just that's gonna allow me to sleep much better tonight, knowing that that chatter is not inside that face. So now we're technically through with the lathe work. All right, guys, this job is finished up. I'm happy with the results now. That I told you that chatter in there was really bugging me when I pulled it out and looked at it right here, and I said, nope, it's not gonna fly. So went back in the lathe, cleaned that face up as I just said. Everything looks good now. I've checked our depth. We're 5 thousandths deeper than the thickness of a standard bearing. We should be good to go. I feel good about the fit there as well on our 6203 bearing. So whenever, I'm assuming that they're going to replace these bearings because these do not feel good at all. So hopefully they'll get new bearings, but that should give that the proper amount of resistance whenever you go to push it in. It's starting to get tight, trying to go down into the hole there. So whenever you go to press bearings in like something like this, you always want to support it in the hub. So support it in the center there in your press. And once that arbor comes down there and starts pushing on that bearing, it should just very gently push down in there. It shouldn't be much of a press fit at all. And that's how they design these fits for these bearings. I have a chart that gives you all of your proper fits for both the housings and the shaft fits for these bearings here. And it gives you a tolerance to go in. And my understanding, what I was always taught, is that they design those tolerances to allow thermal expansion of bearings. Once these are installed in a part and these start moving, they start getting warm and they grow a little bit. And that's where they give you the proper tolerance for bearing fits like that, okay? So I feel good about that. It should be ready to roll. So what this has allowed the customer to do is now they have a good spare part, where this is typically something that is replaced. So this would usually end up in the scrap pile, the trash bin, throw it away because you just buy another replacement from the manufacturer. Now they actually have a good replacement part that they can keep on their shelf in the event that another one of these wheels goes out, because they said that this is a problem that they've already had before. And so they have to order a new wheel from the manufacturer, wait a few days for it to get here, and having this on the shelf allows them to have a spare so that they can go out to the customer and, the same day swap this out and get them back in business while they get another wheel ordered to maybe keep one on the shelf at that point. So anyway, this is going to allow them to have a spare on the shelf, and I'm happy with it. I think it looks pretty good. Guys are probably concerned about, hey, you should have the snap ring in there because that's how the manufacturer made it. All that is a shoulder to keep the bearing from pressing up in there. That's all that's used for. So my fix there with the solid shoulder, there's nothing wrong with that. It should work just fine. All right, so this guy is technically, it is finished up and ready to go. I hope you guys enjoyed watching this one. We had a lot of good manual machine work here, getting to use our American pacemaker and our Precision Matthews lathe. The new collet chuck from Pee Wee Tools, that worked out really good, and I'm happy to have that one. And I just hope you guys enjoyed watching the project, and I hope you come back for the next one. All right, see you guys then.